My name is Chase Malackowski. I am an amputee, athlete, and applicant to the Jimmy Iovine and Andre Young Academy for Arts, Technology, and the Business of Innovation at the University of Southern California. I want to spend a few moments to share my view on how these three traits fit together. My right leg was amputated below the knee when I was 9 years old. As inspiration, my family shared with me a number of videos showing other children with the same experience skillfully managing a soccer ball. I knew then my goal would be to master my new normal condition and compete without excuse or limitation. Fast forward more than 5 years, and indeed I found myself striving to capture a spot on my high school soccer team. I quickly realized, however, a number of problems. My prosthetic was a limitation after all, not because I was an amputee, but because of the way prosthetics were generally built. Prosthetics have advanced significantly with respect to meeting the basic functions of everyday use. The popularity of the Special Olympics and other sports featuring disabled athletes of all ages requires that the prosthetic limb technology advance even further. With respect to current prosthetic leg technology, there are two general formats. A one-piece hollow hard plastic socket that extends to the prosthetic foot, or a hard plastic or similar material upper portion socket with a metal pylon connecting the socket to the foot. Current practice seeks to make the socket or the socket and connecting pylon as rigid as possible to assure a maximum strength-to-weight ratio. Current practice also teaches away from making the socket flexible, especially in the case of a one-piece structure, even though a flexible structure would be more natural in response to a sporting contact. From my own experience, I soon found that the central pylon, which connected the socket to the foot, was itself horrible for trapping and controlling the ball, often sending it in erratic directions. While prosthetics that are shaped like natural legs provide a better surface area for ball contact, they are typically made from a hard plastic and do not provide realistic compression of the surface area, preventing the needed ball control. Plastic prosthetics imitating natural leg form are also far too fragile to stand up to intensive forces required when running on the field. My solution was to surround a rigid pylon in medium density foam and then laminate over the foam with a thin layer of carbon fiber weave. The result creates a cushioning effect when the ball is trapped, as well as an internal skeletal structure sturdy enough for powerful shots. I also modified the shape of the shin area to create flat spots where the carbon weave was thinner or thicker, depending on whether the area was used to trap or shoot. This improved shell was then paired with a Rush polymer athletic foot for better speed and agility. I have termed my invention the prosthetic sports leg, or PSL. My invention alters the basic form and structure of a prosthetic limb by doing the following: reducing the circumference of the socket as well as the diameter of the pylon, the addition of a molded low-density memory foam surrounding the pylon, the addition of a one-piece flexible outer laminate layer, ideally covering the entire length of both the socket and the pylon, a laminate layer comprising of a variety of materials, including a thin layer of carbon fiber, attachment of the laminate layer to the socket by alternative means, including attachment to the upper interior rim of the socket or as an attachment interface at the bottom of the socket. Providing access through the laminate layer enabling full adjustment of the inner pylon and prosthetic foot. The laminate piece may be removable to allow for quickly altering its thickness for various sporting applications, as well as to allow for various alternative exterior designs, branding, or sponsorship platform. The benefits of my invention include the following: a greater control for sporting athletics through the greater surface area of the laminate as compared to a traditional pylon, as well as the flexibility of the laminate material as compared to either a rigid prosthetic socket or a pylon. The quick alteration of the prosthetic's performance via the ability to substitute laminates or foam substance of various rigidity, a user-centric design, branding, or sponsorship platform, and a more natural appearance as compared to a pylon. Following the completion of the PSL project, I filed for US patent-based protection on the material composition and structure of my design. I believe that the scope of my invention can be defined by the following claims. My invention was based on my personal experience, as well as other projects that I have worked on throughout high school utilizing CAD software. The process of describing and documenting my creative expression in a formal patent application stretched my innovative thinking even further. I feel that this experience has not only helped me physically in the form of my improved soccer play, but also provided me with confidence in my own unique approach to innovation. I believe that the process of developing the PSL will allow me to add perspective to my participation in the Jimmy Iovine and Andre Young Academy for Arts, Technology, and the Business of Innovation. I look forward to this opportunity.